This is an extension of my lecture on the fundamentals of physics. The Heisenberg uncertainty principle dictates that the conservation of entropy and the conservation of energy, the quantization of the universe, the conservation of everything as nothing dictates that something which is dead is also alive, meaning that Heisenberg-wise, something that is very nearly dead or is dead, the universe cheats. The universe cheats. It cheats to exist. It cheats to create life. Things like quantum tunneling and stuff. So the Heisenberg uncertainty principle even applies to fractals, like the Mandelbrot set. Because you notice as you take the tangent to the Mandelbrot set, as you get more and more specific, the tangent varies over everything. So it's very nearly, I believe you'll find laws fairly interesting with respect to that set. For instance, the Heisenberg uncertainty constant is just the line integral measure density of the Mandelbrot set and things like that. And I'm not sure what that means for a solid state physics, but it's really quite an interesting result. But yes, I pay strict attention to fractals. Fractals are basically where it's at. It's the way of the universe. And you ask, what is the convenience of a fractal? Like, what does it mean that the universe is fractaline? It means it's kind of like the Penrose null tetrad is way overdone. It's a ridiculously complex theory. But basically what he's saying is that rotation is displacement, displacement is rotation in curvilinear coordinates. Well, in a fractal, you just have something displaced and rotating to create complexity. But what is complexity? It's just richness of span, meaning that the infinitely small subsections represent the whole, meaning that the universe is self-repeating, a self-subset of itself, not a superset of itself, but a subset of itself, meaning that it conserves energy that way because it is more simple to say that it is a subset of itself. I mean, you have to do less explaining, less work. And that's basically all energy conservation laws are about, is the universe trying to remain as simple as possible, using as few rules as possible. So my theory basically says that the first theory is something called the dichotomous tetrad, meaning that there's a tetrahedron of duplicate theories, everything explained in two ways, and there's a map, like a linear map, from one direction to another, which is held at any particular time. That's the first theory I use. The second is bifurcation, meaning that it's like sex. The universe splits into twos over and over again because it splits in half and then it splits in half again, kind of like something walking, like 2 becomes 4. It's kind of like people having sex or people walking, meaning that the particles split. There's 2 forms, parallel and anti-parallel, meaning that like perpendicular, they come and they split. My third theory is the Casimir equations, which is an expression for the conservation of angular momentum, meaning that even though that things like force and direct force and rotation alone, like direct linear displacement, produces it doesn't hold conservation laws because it's too infinitely quantum mechanical, involving every single mathematics that can ever exist, which is the nature of the subset of space, that subsets of space like quantum space include every mathematical theory that could ever be invented for completeness. That's why people like Witten and Penrose will never get anywhere. Even people like Gubser, who's mainly a theoretical physicist, make very little progress in their lifetimes because they try to think too mathematically. Kaku is indeed gifted, but he tends to focus on the wrong things. Like he just kind of digresses and doesn't really, very few physicists pay attention to fractals. Now my fourth theory is fractals itself whole. The universe is a biological fractal, meaning that it tends to explain itself as a complete whole, meaning that it's just a giant fractal. And the fifth theory, which is redundant in some sense, is free space. Any one of these theories alone is a reality, but they don't exist independently. And also, you can't take three of them and make sense of them because it takes all four. Now, the ingenious thing about this is that, in some strange sense, these theories, the free space is 0, the rest of the theories are 1, 2, 3, and 4. They tend to rotate around one another, meaning that I believe there's a simpler form of expressing them using advanced logical connectives, meaning that abstractly there's a complete theory of the universe in terms of abstractions, which I mean quite abstract, like an algebra of algebras, kind of like the Galois extension in abstract algebra for two variables. I'm not even sure if that kind of thing exists, but what I'm saying is that they tend to be patternistically similar, meaning all four theories express something about reality in a very real sense. And so the numbers 0 through 4 and 0 through 3 play a role in physics, like the Riemann metric, my theory. And the numbers 1 through 5 play a role too. So as the numbers 1 through 6 are the period of the circle, 2 pi, like periodicity in complex numbers. And numbers 1 through 7, 7 being a transcendental number, meaning that it's the closest thing to God in my theory, like something extraneous to the known universe. I'm not sure whether this universe bifurcates or becomes another universe in the next universe, but only that it appears to be at no less than 2 universes, each one wrapped around the other in a Mobius strip. So the universe passes through itself. At the equilibrium point, you have 0 mass, then the universe rotates for the strip, and you have something massive, and then it rotates back again as you go around, and it becomes massless again. And it might be that one universe is on one side of the strip, the other universe is on the other side of the strip, meaning that the next universe might just be the logical negative of this strip. Like you take the space coordinates, you map them across each other term-wise, so that what becomes x becomes minus x, the other two coordinates remaining the same. And that would work to balance things out because you get 0 displacement, 0 measurement, and that kind of thing. It's fairly clever using 2 black holes and 2 universes with opposite coordinates to cancel out any known reality. In fact, that is my contention why the Cauchy-Riemann equations hold. Like, explicit analytic coordinates for any Laplace potential in 2 dimensions. And it's known that it doesn't hold in 3 dimensions, but what I'm saying is that one of those dimensions is minus x to x, the symmetry in the 2 universes. Meaning the other 2 are explicit because it's what is real and really expressible. And that's the way it works. The importance of what Nikola Tesla says of 3, 6, and 9 is noted here. That those 3 numbers are very important because when you take 3, like x, y, z, subjected to strain or quantum strain, like the Heisenberg uncertainty principle and fractals, you get a rotating term. I mean, you have to use tensors, which is 9-dimensional. Likewise, for complements, when you use 3 to 3 coordinates, you get negative 3 coordinates, xyz, negative xyz, or for tensors, xx, xy, xz, and so forth, 3, 6, and 9. That is how I make my progress. Ironically, the Kakemer equations, which is expressed as, and each one of these theories are kind of elaborate though, because my Kakemer equations were the first one I evolved, and it's basically 27 equations and 9 boundary conditions, written as a grand unified tensor, which is fairly elaborate because it's so massive. And each one of these equations would say something about the universe, like nothing is impossible, nothing lasts forever, da da da, nothing is anything, like those kind of statements, which have two meanings actually, and perhaps even more. I would suggest they each have 2 to 6 meanings, probably no less than 3. But logically, what it means is that each statement had 3 meanings and one null meaning, meaning that there were statements about nothing and something and anything and everything, and even statements about possibility, like nothing is possible, nothing is anything, nothing is everything, nothing lasts forever. But you can derive using quantum mechanics the statement that if you measure something twice, you have a frame of basis because the displacements all cancel. Meaning that if you measure reality twice, even with quantum mechanics, you get no uncertainty, meaning that something has to spring into existence so that it becomes certain that nothing is uncertain, or rather certain that nothing exists, therefore something exists. It's just logical, word logic. And logic is more fundamentally one of the fundamental tenets of physics, meaning that it's a fundamental, inescapable truth that logic holds in physics, meaning that the universe is reasonable and logical. Quantum space becomes infinitely complex as you move down, and the conservation laws are just the universe trying to keep it simple and be economical because it came from nothing. Therefore, it tries to approach nothing as constantly as possible to stay nothing. And it is nothing at any particular time quantum mechanically, because it doesn't exist in all 3 dimensions at the same time. In fact, if you measure all 3 at the same time, you get nothing, meaning quantum Heisenberg-wise, it becomes something, hence unpredictable. God does not exist in my theory. I can't begin to tell you how wrong most of those scientists are for thinking that life being impossible on Earth is proof of God's existence. People that say that the universe couldn't come from nothing, and people saying that look around us, look how wonderful this all is, therefore God exists. Look at animals, which we decide to kill, by the way, to eat for food, saying, oh, look at animals, this is wonderful, therefore God exists. Look at how complex physics is, therefore God exists. I can't begin to tell you how atheist modern physics is. Even the one imagined by Penrose and Witten and Hawking, and Hawking wasn't a great physicist, by the way, either. But anyways, Penrose, Witten, Kaku, and Gubzer. It's atheist. There's nothing religious about it. Quantum mechanics was never a theist doctrine. They never believed in God. It's so fundamentally convincing that nothing exists, therefore the universe is just a rearrangement of nothing, like con artistry with respect to nothing. But you see what I'm saying? It's kind of like 2 sides of a wave where it wavers and it cancels to nothing, but on either side you have displacement, therefore it can exist. Symmetry breaking exists only for the sake of quantifying the statement that nothing makes any sense. And nothing does make any sense. But the thing about that is that if nothing makes any sense, then the statement that nothing makes any sense doesn't make any sense. Meaning you have to have symmetry breaking according to my Kakemer equations and according to the 27 rules which the Kakemer equations obey, and the 9 boundary conditions or continuity conditions. Rings and circles are composed of elements. The elements being that you have like an arm, a rotation, an angle, and a curvature. It's composed of only so many things. It's basically these simple ideas that I build my theory of physics around. The wave equation, however complex, is really discoverable by Greek mathematics. And I've done that before. I used Greek mathematics to prove theorems about second order partial differential equations, elliptic equations, the completeness of the Fourier spectrum, for example. Another thing I have to say, which is quite revolutionary about what I believe in physics, is that entropy is conserved. A lot of physicists don't believe that, and the existence of black holes means that particles quantum tunnel all the way across the universe instantaneously to create conservation of entropy, meaning that the universe will end in a black hole because and that's the neat thing about the shooting method, is that as the universe extends infinitely, it has just barely enough energy to capture the last photon that escaped when the universe was first created, like several billion miles out there in space. It's fairly ingenious the way it works. The black holes are just quantum mechanically sucking out all the entropy, because the entropy is permanently lost beyond the event horizon. Well, entropy is constantly increasing in ordinary chemistry, it's constantly decreasing in black holes. Those two cancel each other. So the idea of life existing is just the Heisenberg uncertainty principle applied to nothing, meaning that when you take absolute nothing or very nearly nothing, say that it is dead, Heisenberg-wise, that means that there's something alive because it's certain that everything is dead. Therefore, it becomes uncertain that there's something that isn't dead. It's just the Heisenberg uncertainty principle, and that is the guiding torchlight to my new form of physics.